For the first experiment, we will want you to build an Arduino which switches LED light on and off, in a sense that not every press will switch it on and off. However, whenever you press the button, the LED light will go on. Whenever you let the button go, the LED light will switch itself off. So for this experiment, you'll need your Arduino board, obviously the blue part. Then you'll need the breadboard. That's where we usually and always construct our circuits, test circuits. An LED, it will be really up to you which LED light you choose for this experiment. We'll need also 220 or 100 ohm resistor. You can use 100, it works with 100, or you can use 220, whichever one is easier for you. And we'll need a 10 kilo ohm resistor as well, 10,000 ohms. And then we'll need the push button itself as well. You can see the components on the screen here, so it shouldn't be a problem. I hope you kept them in the little strips that there are, so you know which one is 10 kilo ohm and which one is 220 and 100 ohms. And of course you'll need some wires. We do apologize, we are having problems with the Fritzig program, so we cannot show you the schematics of how we construct the actual circuit. However, we'll use a video to show you how we do it. So now we're ready to construct our circuit with the button, push button to switch the LED on, and then when we leave the button or let it go, it's going to switch itself off the LED. So as I said, for this experiment you will need the two resistors, 220 ohm and 10k, 10,000 ohms. So I have the 220 ohm on the left hand side and 10,000 ohms on the right hand side. I've already pre-installed the button. It is a good practice if you pre-install it in between two of the separations. It is big enough. And then I've got my wiring. I'm going to use the red wiring for 5 voltage, the black wiring for ground, and yellow for the ports themselves. So let's build it all together. First all that we need to note is that the button does not really have any, like with the LED, pluses or minus, as long as we have the D5 and the ground on one side and the porting on the other side. And you'll see what I mean by it in a moment. So the 10k resistor will go into one of the legs. It's up to you which one you use, and then we'll just put it far away so it's easier to ground it that way and the wiring is not on the way. And then we'll put it, as you can see, the LED light, the longest part again on the right hand side, and that's where we put our resistor. Again, I am doing it quite far apart, so it will be more visual for you to see. Then the button gets grounded through the actual resistor, and we need to find the ground port here, and we have quite a few of them, so I'll use this one. For the red one, I'm going to use the 5 voltage, which is going to be fed from the other leg, the opposite one from the actual ground. And I'm going to find the 5 voltage on the Arduino itself. And then all we need to do is port it and ground the actual LED itself. For the LED, I'm going to use a brown ground wiring, and for the porting I'm going to use, so it's going to be the other leg on the top leg here. You can use port 7. I'm going to ground the LED light. It's a bit far away. anyway, so I'm gonna use the other one on the other side, which should be good enough. And then I need to obviously give it a port as well. I'm just gonna use a white wire because this one is not reaching it, it's gonna be too tight. And I'm gonna use port 5. Just very quickly, I'm gonna upload the code and we'll see what happens. Button 7, yes. So I've got all the ports correct here. Just compiling the sketch and then uploading it. So our sketch is uploaded now, and when we switch the button, the light should come on. And when we leave the button or let it go, it will come off. Okay, so I hope no one had a problem with constructing this circuit. The circuit is pretty simple and shouldn't be a problem for any one of you. So let's have a look at the code. I have slightly changed the interpretation of the button, so I use 7 and 5 instead of 5 and 3. But as I said, you can use any pins and it won't matter at all. Then I had to give a definition to button state, and I gave it the definition to button state as 0, which means it's false. This is assigns the button state, so when you switch the circuit right from the beginning, the button itself will not be switched on, it needs to be switched off, so we give it a state right away. And then we're introducing obviously the button pin here as well, and the button, because we manipulate it or we use it to do something, it will be an input rather than output. An LED light, we cannot press it to switch it on, hence it's always an output, but the button we can press it, and that's why it means it is an input. It's something that we can manipulate, we can use to do something. Then we can look at the void loop, and the void loop will start by button state equals to digital read button pin. So what it does, it equates the button state which we defined at the top, 0, and it writes the state of the button. So when you haven't pressed the button yet, the state of it will be 0, and it's ready to take an input from you. And that's where we introduce the if command. So the if command uses if button state, remember the double equal sign is equal to from the common operators. If the button state is equal to high, then it will execute the statement digital write LED pin high. So it will switch the LED on. Remember, high it's on, low is off. However, then we also have a statement where we have a function else, and the else function also states that the digital write LED pin is low. So what happens within the code here? We give it a condition, and the condition will have to be either one or the other. A condition cannot be just one, that's why it's a condition. When you have a condition, you have minimum 2 outputs. So the condition states that if the button is high, the LED light will be high as well, so it will switch on. However, if that's not true and the button state is equal low, as we saw at the top, it was defined as button state low. So whenever we don't press the button, it says if the button state is low, else execute this command, digital write LED pin low. So let's just recapture the if function. The if function is used to compare a condition, or sometimes it can be even more than one condition. It can be multiple conditions, whether they're true or false, and then execute a statement or statements. Again, the if function can have more than one statement within itself. So if you have several components, then it can be executing several components in the way you need them, and if the condition is true, otherwise it will skip the statements. And when it skips the statements, so our Arduino doesn't get stuck, or let's say we wanted to do certain things. Let's say, for example, if we have a sensor of some sort, and then when the sensor is not active, let's say we wanted to give us a noise. So we'll use a passive buzzer for it to produce a noise, and then we know that the sensor is not working, for example, or it's not picking up a signal of some sort. Again, it depends what sort of functionality you want it to be, but the else, if and else statements are quite close together. You don't usually have an if statement if you don't have an else statement. So again, it's very useful when we work with multi-components. So far we've only been working with LEDs alone, but now we're introducing more components to our circuit, and that's why we have to use the if function. The if statement will always use a common operator to compare conditions or states. As we saw in the code, the previous button state was a 0, and then when the if function was executed or started to execute itself, the first thing it compared itself is the button state. It had to compare, okay, so in what state a button in at the moment, and is it equal to high or low? Obviously, when you press the button, you're sending through a signal, and the signal, as I said, 5 volts compares to 1. Because again, we're working with the basic true or false, 0 or 1, high and low, 0 volts, 5 volts, they all have the same pretty much meaning. And when the button state equals to high, so whenever it sees a press, you holding the button, you will see number 1. For example, we will have a look into more detail of how to work with the serial port and how the serial port will display that input from ourselves in the next lecture. So that is the if function. It's pretty useful, and we will be using it more and more intensively as we build bigger circuits. Then we have the else function. And the else function, we need an escape clause for the Arduino in case the if function does not become true. Otherwise, in this particular circuit, yeah, the LED would have stayed off as well, of course. However, as I said, when you build the bigger circuits, more complicated circuits, you usually want the Arduino to do something else if the function is not executed. So yeah, we do not want an Arduino just to stop and do nothing, therefore we use the else statement to give it another function. And in our piece of code we saw that the else was a digital write LED pin low, which meant that it will switch the LED off as it gets executed through that loop. So now we're gonna jump straight into and we'll build a passive buzzer circuit. And the passive buzzer circuit is very simple. It's only pretty much 2 components, a resistor and a passive buzzer. You'll need a resistor of 100 ohm resistor, no more for this one. A breadboard, of course, as again we always use it, Arduino wires, and the actual Arduino Uno itself. And we're just gonna show you a video how we construct it and what effect it's gonna give, or what will be the result of it. So welcome to the second experiment, but the passive buzzer. And we want to construct you a very simple circuit of a passive buzzer. And when you upload the code, you will make it a sound. You can change that sound, and we will talk about it a little bit in the actual presentation number 5 a little bit later. At the moment we just want to focus on the actual constructing the circuit. So we have the passive buzzer, we have the 100 ohm resistor, and we have 2 wires. That's all we need. We're going to use a white wire to define the port and a black wire to ground the actual circuit. Don't be worried that with the actual passive buzzers you can bend the legs a little bit. It's not a problem at all. So on the actual passive buzzer you will have a plus side, and the plus side, that's going to be your port, and the minus side, which is the opposite, is going to be your ground. So let's just put the passive buzzer in. I have bent mine a little bit, that's why they go in so easily, but as I said, the very first one, the manufactured one, when they come from the box, they can be a bit sturdy and you need to bend them a little bit. And then we connect a resistor to the plus side, and from the actual plus side we're going to use the white wire connecting from the resistor, the plus side, into the board. And I'm going to be using port number 5, and the minus side will connect to the ground. I've already uploaded my code, and hence you can hear the sound, the beeping sound of the buzzer with the delay in between.
So I hope it wasn't too difficult to construct. Again, a very simple circuit, and here is the code for it. So what we have, again, we define the buzzer as being in the pin number 5, buzzer to Arduino. Sorry, it's a spelling mistake here. We set it as number 5, not number 9. At first I set it to number 9, but then I've changed it, but never mind. Again, it's just the common part. It doesn't matter. You can set it to any pin you want. In the void setup, we set the buzzer as an output. Again, the buzzer is something we cannot interact. It's only giving out a signal or a noise in this case. Hence it's an output. And then in the void loop we set tone, and we gave the buzzer a tone, 1.5 kilohertz as a sound signal, then a delay for 1 second, and no tone, and delay again, and then it loops itself through it. You can change the buzzer, the kilohertz on the buzzer as well, and just have a look at what sort of different noises it makes. You can change the delay as well, and it should be pretty simple. Do experiment with it a little bit here and there, just to see what sort of effects you get from it. You will need it a little bit for the next challenge that we're gonna set up. So now, after we've done the actual buzzer, passive buzzer code, and everything works perfectly fine, we want to set up an exercise for you, an exercise button with buzzer and LED. We have complicated this exercise a little bit more because we think that you are quite capable of combining everything that you learned so far and be able to modify the code. So what we want you to do, we want you to build a circuit where there's a buzzer, there's a button, and there's an LED light. And the task of the circuit is number 1, when the button not pressed, buzzer is on and the LED is off. And the task number 2 for the circuit is when the button is pressed, LED comes on and the buzzer comes off, so there's no sound, or there will be a crackling sound. I hope it will be quite simple for you to construct. If you have any questions, any problems, any concerns regarding this exercise, post on the Facebook, ask your questions. We'll be able to help you with this one. I hope you enjoyed it so far, and I'm quite looking forward to introducing you to presentation number 6, where we'll be looking into more detail of serial ports, how they work, and how we will be using them, or we can use them to aid in our projects. Thank you very much.